In this video, we're going to continue our study of 3D geometry. Let's define a plane that we're going to denote by P. Okay, and let's have a line in space. This line intersects the plane P in this point. Let's call it M. Okay, and let's call our line delta. Okay, in this manner we project points on the plane P parallel to this line delta. So if we take A here, its projection is going to be the line that's parallel to delta and that crosses P in A prime. So this line A prime is parallel to delta. Okay, let's have one more point. Let's assume that this point is B. So we're gonna project B on the plane P by constructing the line that's parallel to delta and hitting the plane in this point B prime, and therefore we have BB prime. The line is parallel to delta. Okay, and in this manner, by using this kind of projecting on the plane P with parallel to delta, we construct a function. Let's call it P from the space E until the plane P, such that for every x it does associate its projection. Our aim here now is to prove that P is not injective. Okay, how can we do that? Okay, so we remind ourselves of the definition of the injectivity for a function. Okay, so if a function has f of a equals f of b, then we must have a equals b. Then we say that f is injective. Okay, to prove that f is not injective, or p is not injective, p the projection which is parallel to the line delta, we need to prove that p of some c, if it's equal to some p of d, then we must have c is d. But since we want to prove that's not injective, we can prove that if we have p of c is equal to p of d, then c is different from d. Okay, but clearly we can see that without constructing the function p or the projection p implicitly or explicitly, we can just show that for any point here on this line b prime, so here if we take a point that we're gonna call c, we see that the projection of c which on p which is parallel to delta is b prime. So we see that p of b is equal to p of c is equal to b prime, but b is different from c. Clearly here graphically we see that c is different from b, but they have the same projection b prime, and this proves that f is not injective. Okay, that's how we prove it. It's that simple. We don't need to construct the function explicitly. Okay, graphically we see that. So here, all this line here, its projection is going to be one point. In fact, we can prove that the projection of delta is going to be m. This line, the whole line, its projection is going to be one simple point. Okay, so therefore many points have, infinitely many points have the same image, although these points are different. Okay, but for us 2 is enough. We can prove that these two, which are clearly different, they have the same image, and these two are different, and therefore F is not injective.